Hello, everyone. Welcome to the broadcast. We're finally getting our game dev stuff rolling again. Feeling ambitious. Feeling like we're going to get somewhere. Let's see where, or at least what somewhere turns out to be. Let's see. Yes, it is advertisement time over there on the Twitch side, and I see Adarius over on YouTube joining us. Oh, creek. Oh, but for those unfamiliar, we've been working on a game development project. We haven't been putting as much time as we would need to move swiftly. But this is the, I believe, 120th stream that we've done this. Generally a few hours worth of messing with it each time. In development terms, that means about hour and a half tops worth of time spent on it. I'm doing well, Adarius. I'm doing well. Let's see. Let's check in with the kitties real quick. We do have at least 4 visible. Sherbet and Molly are not visible at the moment, but we do have Sky, Ember, Mason, and Sammy. That's right, Alt. Finally a dev stream. Finally. Testing a new chat aggregator here. I think that, and then with a bit of modification to my scripting, I can get the alerts and the chat consolidation much more concise. That'll be nice. That'll be real nice. You've been in a few streams recently, haven't you? So there's another alt running around. Zoom in on the tree real quick here. See if there's another jammed up in there. But I'm just seeing Sky and Ember, I think. No, there's 3 of them up there. Molly's up there too. Molly's wedged up in the front. Molly once again demonstrating that she is willing to sit in everybody's spot. Hey, Dodds. Welcome back from Adland. Which is a bit tricky as far as when it actually decides to run them in the rhythm of it. So forgive me if the break timing isn't quite right. But when last we left, there had been... We discovered really an issue with the way that rotation happens. That was a bit after the stream. Like, I had looked at it, saw it, and dug into it, and there was a problem. And it drove me right up the wall. And I had to do a lot of math that I had not planned on doing. Yes, I got the fresh new plugin for it. Okay, so you can see we've got rotation going again. Right now they fire outward, so they have kind of almost like a scallop pattern to them. But if we make a bunch of them fire at once, we should be able to see it better. So you can see these little rings flying out. They're currently set to home to a target, so they stop if they lose one. But we changed a lot of how that works in the background. Let's see. Do you mean like smooth movement? Or the shape of them? Like the visual shape? Smooth movement. Visually on screen, a tricky thing with pixel art, if you're using pixel art, is that you don't want the pixels to be one-to-one. That's one aspect of it, because if the pixels are one-to-one to screen pixels, then every time an image has to move, it will move in whole pixel chunks, and that can be visible. It'll be kind of jittery. You can change that by effectively multiplying the size of things. So the sprites that you're seeing are only 32 pixels wide. The yarn balls are 16 pixels wide, but they're blown up on the screen, so each visual pixel is actually like, right now I think 3 screen pixels. So it's harder to see the movement of the object on the screen, like to see the pixels being the movement medium. As for actual movement in the world, like the actual position in the world, you got to use delta. I don't know if you're already familiar with it. It's kind of a core thing that you need to deal with. But you have physics and rendering. Yes, delta time. So every time the world step, the physics step comes around, we get a time since last step. Every bit of movement should always be altered accordingly. Right now, all of the logic that I have is in kind of screen units per second. So this is, or behavior per second. And this is going to be fractions of a second. Collision. I've tried various forms of collision. Started with pure Godot, shifted to a little C#, shifted to low-level Godot shenanigans. Then eventually we had collision done entirely in compute shaders on the graphics card. And now we're back to Godot because it's performing well enough. And by having the collision happen in Godot, it gives us more flexibility for how a collision can be detected. We'll see how that do, though. We'll see how that do long term. So what we're going to be trying to do to... yes, we're using Godot. Particular version. Right now we're on 4.4.1 stable mono. We're doing our coding in C#, so this is Visual Studio. We only use Godot script for things that it's necessary, which is almost nothing. The only stuff that's actually happening in Godot is the startup logic. So let's get to that. Where are you hiding? It's not game, it's core. Core. I need the scene for that. This is the scene for the game. Where did I put the... there it is. Okay. This is the game. The only thing that this red dot does is it shows us where the center of the world is. This is at 0, 0 in the absolute world. So core is where we start. Let me run it on the Godot side to show you. It's useful to run both. C# lets me get in there and debug in the guts of it. Godot detects errors on the Godot side better. Hey there, Lore. So we pause, we go back into Godot, we look at our scene tree. So the only thing that exists raw in Godot as far as the flow of the game is core. Everything else gets driven by the C# side, even when it is a node that gets added. Everything about this is determined by, well, except like the camera, that's part of the game, but entity manager, all these little dealies are things that are added at runtime. And I can actually, oh, okay, I found Sherbet. He's under my feet. My footrest is a little cat hutch, and he's the only one that sleeps in there. Even Molly won't take that spot or the window hutch. Don't know why. We've got all this working. How's your project going, Laura? Okay, so we have that. Let's resume here. Oh, I hit restart, not that. Oops. For those not familiar with the core concept of the game, we're doing like a Vampire Survivor style thing. The gimmick being whatever the they're modular weapons. I like this kind of system where you're essentially building it up, and the goal is not, did I get the best gun? It's, did I manage to get all of the pieces necessary to make a really good, ideally completely out of control gun? So, like before, we're going to make it be a big pile of these projectiles at once, but we're also going to make them explode on impact. Cool, or that's kind of what we're going to be working on today over on this side too, is loading data from my preliminary CSV. So it went from little loop-de-loops to big clusters of them, and once those little clusters hit, one of them hits something twice, since it has to bounce, they will explode. You'll see the little burst go off, but they have to hit something twice. They will also time out after a little bit. So we can see the explosions there. I saw that, Tess. I saw some of those suggestions coming through. But in an effort to make all of that, here's one of our problems lately. Let me just open up all these folders to show it. Every one of these text files in here is a raw representation of one object in the game, one thing, and it's become a burden to find them and update them. Let me show that again. These right here. I've got a couple of them already set up for that. So by default, when it fires them out, we're going to fire 3 at once, and there's an explosion that will happen on the player. So the yarn balls and the explosion are currently 2 separate things. But if I put one of these abilities on this, right now the shorthand are the ones with the bar under them. What this one says is once a minute, use this one. So now, every second, those yarn balls are going to be emitting explosions. We'll do another. Make this go really crazy. And now we will lag the game. This is both for performance purposes and technically for player victory purposes, what I call a calamity case. There is so much happening on the screen at once that we're seeing the maximum performance. We're down to 17 frames a second with just about 1,600 objects visible at every frame. So you can see some of them as the yarn balls go, this rolling blast going behind them. I'm fine with the performance getting down to such low frames during this, because if this happens, you win. Not only playing catch-up, but you're also generally on YouTube, you're about 15 seconds behind minimum at the best pace of it. So sometimes I'm going to have said something that, or you will type something in reaction to something I'm about to say. So don't worry about that. If you got questions or comments, just fire away. There's no concerns on that. That said, though, I do need to step away real quick. We're back. Oh, interesting. We just got a fail here in area 2D. Yeah, at the very least, like a little burst so that you can see that they are going away right now. All right. Tell me, Stack, what's going on? We might have to have a check to make sure that this thing still exists, because it's possible that we have like a really tight race condition here. But it should not be possible for us to have them go away that fast. Because until that collision happens, there's nothing in the game that removes them. But I wonder if... That's why. Okay, explosions are weird. That's why. Because as soon as this entity came into existence, the collision manager gets the message, but I wonder if we can get a circumstance where the timeout is already happening on it and the collision area is going away. We'll have to see if we can recreate this later. Yeah, right now, all of the graphics are sprites. For things like explosions, I may be shifting to, I'm likely to shift to particle emitters. They'll feel a little more natural to it. But everything is full, like, the explosion is like 6 frames, with the last frame being it's gone. Now I just want to see that happen one more time. Okay. Because the entity that the collision area was referencing was an explosion. And I'm still not quite satisfied with how explosions function as entities. Because they need to exist for a period of time. What I might just have to do is make it so that the timer event doesn't destroy the entity. That technically it can exist for one more tick, you know? It is set to go away. But that could still cause problems based on when it's there. But if it's set up to go away during the process, but because that frame is active, it still gets to exist, then, you know, maybe it'll work better. But that'll be something to revisit in a little bit. Look back here. As is traditional, I get real distracted during coding. That's part of why this project hasn't moved as swiftly as it could. Oh, that's right. That one was removed. No, it shouldn't be there. That should be there. Okay, yeah, we changed it to collision health. And that's fine, folks. You are not expected to know anything about coding for this. If you have questions, ask away. What I generally tell everybody is we're all learning together. For one, if you ever stop learning when you're coding, you're in a bad place. But additionally, I didn't know any Godot code, and I hadn't coded this much C# before this project began. I'd done C# and C# adjacent things, but definitely never did the Godot integration with C#. What we're seeing right now is also why we've got some problems. Is that this project doesn't believe that that file is there, but I don't care about that. The project should not care about the individual files like this. At least I don't want it to. So let's look at our yarn ball here. Targeter, data, behaviors, entities. So right now, we've got group yarn ball. This is another thing that will be changing. Groups, group yarn ball. So we have rotate out. This is the one that's added. So then we also want movement rotate out. And right now we have random enemy, which rotate would normally not do. So we're going to say targeter empty here. This is the equivalent of not putting a targeter, but I want to be careful about that. By discretely entering a empty targeter, we can avoid code assumptions for data types. Okay, so what this wants to do during its behavior, what it's set up to do is, if you notice, those rotations ended at a particular radius, like the circle didn't get any bigger. That's controlled by this is starting radius, how big the radius changes, how much it changes per second, and where it stops. So right now, the radius is set to stop at about 1 square, which is what 96 is about 1 square on the screen at the moment. So it will take it about 3 seconds to hit its maximum radius. But we've removed the targeter element. And if we look at our, where is it? It's bullet yarn ball. Where is group yarn ball? So it has a lifespan. It hits for 1. If it gets struck, it hits itself for 1. Another thing that, oh, I'm sorry. It has 1 health. It hits for 1. When it collides, it hits itself for 1. This is another thing I want to change, but, you know. So the orbit no longer tries to go to a target, I guess is what we're getting at here. So now when they're emitted, we're making it so that it generates 81 of them per second, just for demonstration purposes. So they don't follow a target, so they're just being left where I put them. But again, Tass is familiar with some of the math that went into this. The rotation is entirely controlled by how quickly they move, what the target radius is. Sorry, how quickly they move and what the target radius is. So back into this again with rotate out. The speed, the movement rate of the yarn ball on the screen, like along the arc, is 96, about a square per second. That, paired with the radius, tells you how quickly it needs to rotate around the object. I'm sorry, what the change in angle is. which contributes to a lot of this. But again, there's a lot of math. But by knowing both of these things, we have control over it. And it is very deterministic. This is like how fast it will move outward, or it will try to move outward, how fast it's actually moving, and where it will start and stop as far as its math. So if we make our target radius really big here, so we're going to double it. And restart. There we go. So the inner ones are influenced by the fact that it's a 3 spread. The rotation of the spread matters. If I remove that, then it'll all arc out a little more gracefully. We do still have the kill condition logic in. This is the player's health bar using arbitrary icons. The equivalent in a lot of games would be full heart, empty heart kind of things. But yeah, we finally got this functional. So one more time with ridiculous amount here. So this is what's happening with a wide spread. And we can make it so that they move around the circle faster. We can make it so that the circle is tighter or wider. The circle changes over time as well. But you can do things like remove the target radius and it never stops growing then. So that's how it should work. Timing out before we can see that. There is a practical limit to how fast you can make them spin. Okay, now we have the trippy rotation going on. Then we say once per second, explode. Now, YouTube, well, my streams are limited to 30 frames a second because I generally don't play, like, you know, high-performance shooters or something like that. But with all this mess going on screen, we're at about 30 frames a second. If we remove the explosions again, or at least the effect, and drop back to the yarn balls, the number in the upper right above my ear there, that's the frames per second that you're seeing, the uppermost number. So right now we're back up to over 600 frames a second. Exactly, Dodds, for science. But this is also part of like the effort that we've put into it, is getting it to where we have this level of performance, because with 800 things on the screen, we are able to exceed any reasonable frames per second. Like if this were just capped at 60, like we didn't let it go faster than 60, even if we just did that functionally, in the background we are still processing really fast. And this is physics ticks per second. Visual frame updates can happen at a different pace, but I believe those are capped. Actually, no, I think I'm querying the app. Anyway. But it would be easy to do things like make it lock onto the player. What is that targeter there? There we go. Takes it a moment to shut down. Targeter player. Okay, so the yarn ball is going to look to the player for where it should be. The player is the center. I'll put that another way. Now, if the yarn ball doesn't move fast enough, then you won't get this following effect the same way. So we're reducing the speed of the yarn ball again. So actually tell a lie. Part of the way that the home to target works is that if it spawns right on the target, it's very hard for the target to be lost there. So let's add a little bit of friction to that. Random direction. This is an emphasis of the changes to the way the system can work. Right now, when the yarn balls are emitted, the first thing that happens is we apply that rotation that's intrinsic to the yarn ball. But after that, we apply a random vector that is determined at the time the yarn ball comes into existence. So some of them have a force being applied that is opposite of how they want to move, how they're coded to move, which makes them slow down or almost seem to stop. Sometimes it's with their movement, which makes them seem to move very fast. And we can stack more. So it will try to track an enemy. Now it's centered around the player, which is skewing it even more. Because it's set up to be, it wants to be around the player, is how the rotation works. Or at least it's doing it centered on the player. So when we move, the yarn balls do have a force that follows the player around, applied to them. The same would be true if it was fired at an enemy outright. Is that orbit is trying to converge onto a point where it's centered on its target. If the player moved, if the yarn ball moves in a way that is counter to the direction that the player is going, it can distort that, but you can see as I'm moving around, some of the yarn balls like arc around or pivot around to stay around the player. But effectively what we're seeing here is the core of how the system functions. Is modules, like packets of behavior that all get strung together as we go. How the actual gameplay will work, that's going to vary. So with no random direction applied, they're always emitting in the same way. So we can see they're always going up and left. That is controlled by how you set up the rotation. And what kind of movement they have leading into that. But yeah, so there's our modular system. And what we want to target, ideally today, but if not, near future, is getting all of this consolidated. Again, we don't want much of this. Like, all of these text files here are a bit of a burden. Well then, Laura. Let's see, 192, and then we're going to double it out to 384. They move very fast around the around their angle here. Well, comparatively really fast. Again, the pathway that they're following is very quick here. Now we're going to expand it out into a bunch of them. Let's make it faster. And then that. I've got much more of a fireworks effect going on. Let's add a few more. They split into 3, then they split into 3 again. The fact that the rotation is impacted by the rotation that is caused by the split. So when you split, it fans them out over the arc of the split. Right now, I believe it tries to do a 90-degree cone, I believe. If it splits again, it's a 90-degree cone off of that. So 90-degree cone with 3 of them is going to be, left, right, and center. Then off of each of those, we do a left, right, and center. So it doubles up in the center. In fact, it triples up in this case. And so on and so on. Once you've added if we split 4 times, you have 360 with the center being very saturated. Yeah, so then if we go in, these are all relatively, they're arbitrary. Let's call it 384. We'll expand at 192, so they'll get out there very quickly. And we have targeter still around the player. Yep. So this is the traditional weapon that you would see in a lot of these games. Is fixed distance. So this is your Vampire Survivor's Bible. When they collide and bounce, you can really see it. So because they're fanned out as much as they are, we get some coverage in the middle from these. But if you remove a lot of that, you can more closely see where the actual radii are. Yep, change duration, give them little exit animations, that kind of stuff. And then so a lot of what we're ultimately going to be doing once we're past some of this data loading is figuring out how to get first we're going to get the data loaded in. Then we will work on adding more content, because that's kind of where we're sitting as far as the state of the game. You can die. Like, if you run out of health, the player goes away. There's no further gameplay loop to that. But the core behavior is here. I can bring up a menu. I can mess with stuff. Enemies can hit you. You go away, or they go away. All of that is in place. But we need to make sure that the data loading logic is very effective. Be right back, and then we're going to try to get to that for realsies this time. Back to our target here. There is... You need to close all but this one. All right. So this is where we're starting. This is the logic that makes it so that JSON understands the various types. So inside the JSON file here, we have that this is an item, an inventory item type. Behavior specifically. By default, JSON doesn't know what that is. And I don't want to have to predetermine in the code exactly what that is, because that would be a hassle. So instead, when we are initially setting up the process, we are saying, oh, this is what JSON will use, is the catalog info, catalog type info resolver modifier. And what this does is says, okay, if we're talking about a catalogable, like when you are loading it, this is how we go in and find out which specific one it is. We set some defaults, but then we are going to go through the assembly, the code that is running, right here, get assembly. We get all of the classes that are running in it, but we are filtering them down to ones that are subclasses of iCatalogable, the core class in the data of the game. This interface is effectively things I can load from file, is what this means. So if the thing that we're looking at is iCatalogable, and then specifically if it's a child class of that, which everything that comes in here is, but we're getting all of those types. So behaviors, items, textures, entities, bullets, all of that stuff are going to show up in this list. And then we add to it and say that type is its name is the lowercase of the class name. And then we stuff that value in there. Repeat. We need to do a similar thing in the file loading process because the order in which we load them is important. Whenever we load a file, we need to be able to go in and say, is it a targeter? Because if it's a targeter, that has to be loaded before you load behaviors, because behaviors might talk about targeters. Hey there, Boom. Welcome. We're finally coding again today. So what we're going to do is we're going to add another core type. C# class, and this is going to be we can say info. We can truncate that. Hey there, Lunar. Let's see, a stealth turn-based hacking minigame. You know, you're always joking when I come in. I'm aware of that. But that could be a thing. That could absolutely be a thing. There are elements to the game that we haven't gotten to yet, because core gameplay loop comes first. When you are developing a game, one of the first things that you want to consider is what is the lowest level way to describe what the player does in the game. It's how do you play it in the most simple terms. If you look at like Dungeons and Dragons, we describe a scene, we roll dice to arbitrate what happens. That's it. That's the entirety of Dungeons and Dragons core gameplay. In this case, the core gameplay is the player appears, they get weapons, and they either kill the monsters or get killed by the monsters. That's what we need to accomplish fully. The next layer is how I build those weapons. We're working on that. We're about working on that. Right now, we've stepped back a little bit to how to load data from files. But core gameplay is kill or be killed with the weapons that you get. And you will get swarmed. See, it's catalogable types info. Yes. It's in the Nyanite Survivors library. It is a static class. Tinker Shot. No, I'm really pleased that we do have... There's a non-trivial number of games out there that are working with that concept of modular weaponry. And I mean fully determined modular weaponry, so it's not just the bullet has a buff on it, but full behavioral changes. All right, let's see here. How are we going to do this? There are going to be multiple things in here. Because effectively everything has a type name, which will be a string, and then it will have a type, which is a class. I think we can do that still. Oh, we don't want just the class to be the key, because that is still an issue there. But in that vein, then we need a way to determine what they are. Okay, we can still do that. But we need a class to load this stuff. So what we're getting at... Hey, Harry! Things are going well. Things are going well. Thank you, and welcome. So the data that we're storing is going to be akin to this. We want all of those types, and we want their name. So the name in the JSON file is what we want. We have two different pieces of information that we need to get out of that. One is a type to category combo. That is, if I get a type that is, let's find one here. So this is a collision player type. If I get a collision player type, what I want to know is that it's a behavior. If I know it's a behavior, then I can put it in the behavior bucket. There is some nuance to that I'm going to have to check. So we need to know if it's a behavior group, which is a child class of behavior, before we know that it's a behavior. Sorry, before we categorize it as a behavior. But because I know it's a behavior, I need to put it in the behavior bucket and have that load after all the targeters load. We can see that sequence. Did I put the catalog? There we go, base catalog. There we go. This is the sequence. So we're saying, okay, load all the textures, load all the gates, load the targeters, load the behaviors. Each one of these is part of a sequence. They have to go in this, not necessarily this precise order. There is some room for wiggle, but the things that it's, if something references another, it has to go before. Might there be a programmatic way to determine that hierarchy? Yes, but the broad categories I think we can still determine. And if you're not familiar with the project, feel free to ask me questions. It is not a prerequisite of this stream for you to know what I'm talking about. The core of it, though, we're making a game. comment. We're making a game. The game is Vampire Survivors, but you build your own weapons using little modules that you find instead of fixed value ones. So I can technically on the fly, I don't know if it's going to be on the fly in the actual game, I can make changes to it and they are reflected in how the weapons behave. Let's add a little bit of spin to those explosions. So you can see the explosions are now layered on each other. And then we put the explosions back on this. And now I have layered explosions on top of it. And yeah, Harry, it's kind of a hobby. Would I like it to be more than that? Yes. I do plan on... The goal is to publish this somewhere. We got a ways to go. We are coding this using Godot engine. We're using the C# interface or build for it. This is the first project we've ever done in Godot. It is not my first C# project, but I haven't done anything this extensive with C#. This is our 121st stream of it, which is no more than 363 hours total, I would say. We've had some short streams. A couple long ones, but I feel it probably balances out somewhere. Dictionary. String to string. Okay, so we have two things. We have well, I appreciate the spirit of that, Harry. I kind of agree. Games are a real unwind for me. Real unwind for me as well. Back when Extra Credits was pretty much almost entirely about games, they had a good one as games as abnegation. Games as a way to just not really think about anything. Just play a game, you know? And that speaks to me a lot. You know, are there some games that I engage in intellectually and like really talk about people with it and whatnot? Yes. But there are also times that I just sit there. One of my favorites for that, my type of games that are my favorites for that, are what I call murder simulator. That is playing things like Assassin's Creed or similar, not to be a stealthy, plot-oriented ninja, but to just brutally kill as many people as possible in just kind of a trance. Shadows of War and Shadows of Mordor were good for that. Best orc murder simulators out there. I keep getting tempted to try Hitman for that reason. Feels like a silly way to indulge. Or to indulge in a silly way. A loggable type. I had a lot of fun with Prototype. I'm kind of sad that the game hasn't aged terribly well, just in kind of gameplay and presentation. But the port isn't fantastic either. But I really liked Prototype. Body horror is one of my favorite types of sci-fi horror kind of stuff. Like, I really liked Dead Space. Even the third one, it got a lot of bad press, but frankly, it had a lot going for it. If EA hadn't have dribbled microtransactions on it that were pointless, then it probably wouldn't have caught as much flack as it did. But, you know, such is life. But I love Dead Space. We did play through the remaster of Dead Space 1 on stream once. Seamless subtle plug, go watch my playthrough of Dead Space 1. I did. We also played Carrion on stream, Dots. I love Carrion. Oh, I love that game so much. It's such fun. There's a lot of, the way the controls work, there's a lot of real visceral brutality to it. A lot of games have big kill animations and whatnot, but Carrion gives you that feel of, you know, you have to grab them and maul them manually. That's the thing, Lunar. The thing about Dead Space 3's microtransactions is they came in two flavors. Pre-built guns, which were grossly overpriced for what you got. They were things that you could easily get yourself in the game. Or little robots that would go out and get you trivial amounts of material while you played the game. Well, you would get way more material than you need to make a cool gun just by playing the game a little. It didn't even have that, like, pay to not play your game vibe of a microtransaction. It was just some executive came to them and said, we have to have microtransactions. The devs asked them, hey, what kind? What sort do you want? They're like, don't care, just have them. Thank you, Harry. I'm glad you like it. The design of this character is strongly tied to the lore of the game I'm making. Or the lore of the game I'm making is the lore of my character. However you want to look at it. Hey there, JD. Welcome. Good to see you again. Okay, so the whole point of this static class is to populate these buckets. Type bucket is going to do things like a behavior that is not a behavior group goes in the behavior bucket. This will require some prior knowledge. I can build that into the classes themselves, but that would still necessitate some fiddling. I feel like that might be the way to do it. Yeah, that's the way to do it. Okay, let me explain my muttering. So we have an entity. Entity's base class is this entity. Not that one, this one. Entity extends iCatalogable. What we're going to do is say that every iCatalogable is an interface whose sole purpose is to go to definition, is to define these few things. What is its name in the catalog? Well, this thing. That's all iCatalogable does at the moment. Right now, it's JSON ignored. We might have to change this because the type, this catalog name gets set to whatever the file name is. We may still do this or something like that. So we're going to leave it as is for now. Category. There we go. That's set. Okay. So now we're going to go into this and we're just going to nab this for a moment here. Okay, so again, what this does is at runtime, it's going to go through and say, give me every class in the runtime inside the program that is running, where it is an iCatalogable object. Filter them down. This is our type name. This is an iCatalogable. This might be trickier. We would have to instantiate one of those in order to know what it is. Do for that. There's a way to do that. There's a way to take a type and make a one of it. Look at our catalog. I thought we had a spot. Instantiate copy of type. Yes. No, I have a function called instantiate copy, which is activate or create instance. Okay, we're going to try this. So we know they're iCatalogables. Dot type category. Okay, so that doesn't fire. We're never referencing one of these. Let's just make doubly sure. Yeah. Loggable. Oh, wow, Lunar. Stream's not falling apart for you. Must be refreshing. Applies it to nothing. Use U as the output. Which must have an output marker on it, right? There we go. Right, that run. Yes, by default, Twitch's like lowest latency setting is faster than YouTube. Nature of the beast and all. There is a reason for that, but it is viewer irrelevant. Yep, okay. I invoked that class, so now we're going to run through this. And we're going to execute this a grand total of once. Okay. Now we need to make it actually do stuff. Hey there, Zell. Welcome. My experiments with the new chat aggregator is coming along nicely. I'm going to be looking at a way to get the alerts to operate through that. There'll be a difference in how it functions, and there'll be a couple of things that I have to get set up for it, but I believe I have a way to make it neat. We'll see. All right, so types. Say type name. Value is going to be, oh. Type. Don't care if you actually add it. We're going to try, though. It's already been added, then we shouldn't ever need to add it again. Okay. Again. Right there. It's a behavior group. Yes, it's working. It's not doing what it needs to do yet, but it's working so far. One of these times, you know, maybe if there's ever a 2.0 model, you might be able to see the hand gestures that I do. Which would be neat. I would really like that to happen because you never get to see it, but I got neat mitts. Oh, yeah. Yeah. Yeah, there's an entirety of nanotype off camera. Classy. Okay, so this gives us types, and what this is going to allow us to do is we can skip this part, and instead we can do a for each on types here. Value pair, string type in value. Name .e. Some type info. And then type name. And this should totally not explode. Yay! Okay, what did we just do? Previously, when you think about it, that's kind of how most of the Survivor style games operate. It's not really visible, but the clock amounts to a notoriety thing. The longer it goes, the more trouble you're in. You could have mechanisms to accelerate that, which would be a good foil to you got a really good combo and you're getting out of control. Well, you can accelerate the game and say you're wiping them out so they're swinging back harder, faster. So previously what we did is when we were loading up how the JSON operated, we went through the assembly and got the information there. What we've done is we've separated that out. Now we're loading it in advance in catalog types info. We get all of the types. These are the class pairings, and get those set up. It's currently accomplishing the same thing that it was. So real quickly, let's just get a commit in there for this. Is that other one hiding? I'm sure there's a good reason for it, but does anybody know why they generally call a commit that's ready to be pushed a pull request? Because you push to a repo, you make a change and send it there. Guess that's always just kind of confused me, and I'm sure there's a simple reason. Okay, so we moved all of that out, and what this will mean... Okay, that makes sense. It's if you push, then everybody else needs to pull to update their local copy. Okay. That scans. All right, we have the types info. That's loaded. Now we need to look at when the catalog is feeding. We need to get that information and set it up. We also need to go into the catalogables and set these. I mean, it makes sense. If you have a multi-person project, the idea of a pull request makes sense, because if somebody pushes, you don't want their local commit to collide with the fresh one. Everybody else needs to update it and reconcile the changes, or you can run into, well, you can trample the changes and cause unforeseen consequences. This makes sense. But if you're doing it yourself or in a kind of a tag team kind of pattern, then it doesn't matter. types info. We need our base catalog. Well, we need all the iCatalogables. So we're going to go in and we're going to say we have a targeter. And for base targeter, whenever we are creating one, we need to set it up. Oh. So both of these need to have a core function. Because we don't, what we want is that in this class, there is a static value, like a constant value that it gets set to. And I'd like to not have to set it in two spots. But we might have to. Like, I could have a function there, but it's sort of 6 one way, half a dozen the other. Did virtual void by default, it does nothing. Oh. Oh, I can do this. We want to facilitate this fully. So what we'd be doing is we'd be setting this string. Just throw in something at the wall test. Can I override a constant declaration of a variable in the definition of a child class? So, you know, could I subsequently have logic in the declaration of the child that says type category is equal to something else, or do I need to build it into the constructor? Tell me more, Taz. Because otherwise I have to do this kind of song and dance everywhere, and I don't wanna. Public string up. Right, it's a property though. Yeah. Neat. Now, the override pattern, object-oriented pattern paired with the fact that C# only allows one interface and one parent. It's really just one interface. It allows single inheritance, let's say. Means that there's a linear daisy chain. Now, what you want to be careful of is overriding a function in breaking some core assumption. So, like, if I were to instantiate a targeter and not call base, so I do not call targeter and targeter does not call its base, then a lot of these variables don't get set, and everything wants that to happen. Okay. That is true. Because with an interface, interfaces are grafting on additional functions. Like a pure-blooded interface is just, it has an API. It has a front end that you can invoke that matches that. My catalogable is not fully an interface, since there's like technically function that happens, but in spirit. Because there's never something that is just a catalogable. It is something else that implements that front. In theory, I'm not using this anywhere else. I could just have the string there, but... In case I ever need to reference this somewhere else. Actually, I will need to reference that somewhere else. I'm doing the right thing. JSON in the C# base implementation of JSON that is available in system.text.json.serialization by default attempts to serialize and deserialize any property. This property should never be in the actual JSON files. So we're telling JSON, ignore this. Don't try to read it or write it. behavior. Empty behavior is just a behavior, so empty behavior doesn't need to be special. Now, because the subclasses any further don't override that, we're okay. Messages aren't a cataloged type. All the rest of them are set. So then we have a gate. So I'm going through and setting all of this so that the dictionary can then load them up based on a sequence of events. Now, we're going to be able to simulate that before doing the CSV cutover, which is great. So there's gates, we've got targeters. We got spawn points. Spawn point is one that I want to revisit later. The whole spawning loop needs a revamp. I want the spawners to, instead of being poked, raise events. They get told time has passed, and then they raise an event as to whether they should, whether they're going to spawn something, whether they are done spawning, all of that kind of stuff. So then, now that we've got those loaded, we go into the catalog, our base catalog. When we are loading them right now, we're going through and saying get the directory, load all of the stuff. We're going to add a separate function into this. So when we're getting the directory file contents here, we are not going to JSON parse them right away. So right here, where is it? Yeah. So we deserialize them right here. We're not going to do that just yet. We're going to move that to... We need a series of collections. So we're going to... We need a series of... We need a layered collection that is a series of buckets. These are going to load stuff into the buckets. So this will read it, close the file. Then we're going to go in and we're going to do this try and load pattern here. just going to be catalog name is the file. So we're going to have file name paired to JSON string. So that is a string. We call you we could do an interim, but this is still ultimately doing the same thing. So what we're doing is we're going through a series of directories, finding them. So we say this is the path to directory. We're looking for everything that is a text file. We get all of the files out of that directory. And we spit back. We have a file stream that comes out of that. That file stream is fed into the deserialize process. But is there a different way? Can we... So we can take a file stream, take an element, document, it can take a string. Okay. It can take a string. So what we're going to do... We could just do file read all text, which will spit out a string. Will this work the way we wanted to? Don't know. Gonna find out. Okay, so load files, we have a series of paths that we're trying to load. We could just say data folder and then navigate down through it. Hey, Forsaken. Welcome. Things are going well, Forsaken. Things are going well. You are being greeted by Alt in the other stream. One of the other streams. There in widescreen. We're doing a little exploration here. Enumeration, options. Accessible. Okay. So by adding this, what we can say is read the data folder. We could just say read the data folder. This will go through all of the child directories, and because of what we just did, we don't need to care about it being a texture wrapper directory. We just want to get the text files from whatever structure is in there. Ultimately, we'll be looking for CSV files, but not now. Instead, we're just going to say load the data folder. Okay. r.txt. This should give us the entire listing of files and the entirety of the data folder. So then for each file, instead of file.open for read, we are going to get the whole text. Read all lines would get us a string array. This will be useful when we get into the CSV. For now, we're going to do read all text. It's not really what we want to be doing, but we'll get there. Again, what you just saw happen was one of the things that AI is actually good for in coding, and that's doing actual text completion as you're coding. The reason that it's good at that point is that I can look at it and say, that thing that you just tried to do is not total nonsense. But if you let it write all of the code for you, you will steadily fall into the trap of just trusting it. And I can tell you with certainty, even this text completion comes up with total nonsense periodically. And it's supposed to be drawing its patterns from my files, which it can't possibly be doing because, once again, total nonsense. This is a string to string. We now have a dictionary. Okay, it's not a string to a string, it's a string to just a straight up collection. Doesn't need to be a list. Oh, it can just be a list. File name. It's that. So this gets us the raw name of the file. We are going to do that differently in it, where we're going to give it a fixed name in the catalog. Like, the data file will specify what this is afterwards, as we are parsing that CSV string. Because instead of just reading the JSON out of the file, we are going to be building it here later. So now we have the text for the file. Okay, we're going to catch 22 here. We need to hack this a little bit. All right. This is going to be a string to string. Yeah, pretty hacky what we're doing right now. We are going to manually add the types associated with this. Oh, but that, yeah, it'll still work because this will be path to type. Just so. Texture needs to be set. Rendering. Texture wrapper. Okay, where did I put that? Part of the HUD. It's not part of entity or inventory. Oh, dear, dear, dear. Okay, be right back. And we're back. Okay. Texture wrappers. Where do texture wrappers live? Right there under my nose. Is a catalogable. And we need to get this pattern here into texture wrapper. Ugh. Hands aren't obeying properly here. Okay, back to the base catalog. Logable type entity. It's texture wrapper actually. Weird. players maps. Targeter. Okay, so what we're doing right now is we are brute forcing this a bit. Because if I was parsing the CSV, part of the CSV would be to give me the type name. So, move, rotate out kind of thing would be the type name. Previously, the file, or not that. On here, bullet wind up mouse. It would give me texture wrapper as the first thing. That's what I'm defining is texture wrapper. By using that, I can convert that into a type object. And the type object can be different ones. But ultimately, so I could convert the type into the bucket type. So doesn't matter what kind of targeter I've got, it's always going to go in the targeter bucket. We are wrangling that differently, but our 6 paths there. So normally what we're going to do is we're going to go into groups last. We are going to go into groups first to do proof of concept here. And that, and that. Behaviors are the one where most of the problems would happen as far as sequence of loading. There we go. And we are going to do the same for entities. Once we get to the point where I'm consolidating those files into the CSV, we'll see what we'll see that the complexity of the file structure can be greatly reduced. Like, still just having an entity file is probably viable. And just having a behavior file, but then I don't have to worry about having dozens of different behavior folders necessarily. I can just have, this is the behavior master file. It contains all of them for the base game. This will also make loading mod folders way easier because it won't care about my file structure and it won't care about the mod's file structure. It's just going to hunt down CSV files and parse them. I need spawner item as well. Spawner item is a catalogable. Yep. Okay. Spawner item. Spawner item. And back into the base catalog. Entities path. Now we're going to do spawn points and spawner item. We're going to load entities first. Entities would need every bit of this. Targeters need gates. Oh, behaviors in targeters need gates. Spawner items need spawn paths. Spawn points. Take items and we'll load those up top. Item list also needs that. Hello, Ember. Hello. Ember has come to sit with me. She gets pets. And she very actively disrupts my ability to do just about everything. Molly and Sky still snuggled up in the tree. Let's zoom in on them. Yeah, I know. I stopped holding you, Ember. I understand. If you don't properly cradle her when she's like this, she'll stand up and then she'll try to crawl forward to brace herself better. But that generally just means, you know, my right eye is totally obscured by cat during the process. But look at those two. He's all comfy. You know. Item. I acknowledge you, Ember. I do. World map. He is is in full nuisance mode here. I have a limited amount of time to dart forward and type. Alternately, hunt and peck typing in between lavishing her with pets. They'll let me show you the code that I was typing while we were doing that. Hey, chill. Okay, base catalog. Now we need levels path. Okay, so now we have all of the file paths mapped with their types. String. And is odd. File path. Files. File path. To the key. So now we have type name. We have the name of the file. This is the thing we're going to load. We have the text of the file. We can actually prep this here. As file contents. If it doesn't already contain the key, then what we're going to do is add that. Just so. Again, this is kind of kludgy right now, so I'm having to think through it. Again, when we're actually reading the CSV, we won't need this nonsense. We'll just read the whole data folder recursively. File contents. Dot. You keep doing that. Okay, so now we've loaded up all of the data in those folders by doing this. We're going through and we're saying, all right, this path type, for each of these file paths, we're going to iterate over it. We're going to say this is the path and this is the type that we mapped it to. Path to type, path to type. If we haven't already created a container for that, we're going to add to it right now. Then we will extract all of the files from that. For now, we're not actually going to use options. We don't want it recursive. We're just going to do exactly what we're giving it. Then we're going to get where we get all of those files. For each one, we are getting its name, so we're getting the raw file, file with no extension. So whatever that file is called, we're going to put that as the name. We get the entirety of the text from it. We add it to the pool. Then for each list of strings, in file contents, values. There has been some change in the core settings of this file, or at least how it is anticipating it wants me to operate, because it is using a double indentation, and I hate it. Hey there, Mystery. Right there, how it's jumping forward that far. I don't know why it has started doing that. It's not supposed to be doing that. Let's open, close. Why is that wrong? Oh, dangling brackets. That might be why it was messing up, actually. Do this right, we won't need that. I can't, mystery. I can't say I recall. Well, I know what the PS2 meme sound is. Each string file content in the content list. File name, just like before. No, okay. This can't be a list, it needs to be a dictionary. String. So add file name and file text. So now here's the content of the file name. Each dictionary in values. Where a string to a string. New file content pair.key. That's the key. This is the value. Ape. Okay, this is likely to explode in my face here. Let's see how it do break, though. Items. Oh. File. File. Same thing. Now we have to find all the things that I missed in the process, you know? It's collision bounce. Oh. We need to load them in order now. So we're not iterating over it in this fashion. So we're going to make a method for this. I could set up a constant load order. This is a protected read-only. View of string. Velocity, you can take a collection. Takes a collection, and each of these is going to be the original load order. So we need this effectively. For reference. Hey there, Raptor. Welcome, welcome. Good to see you. Make it read only. So I'll be explicit about that. Doing well, Raptor, doing well. We are in the process of rewriting our file loading to some extent again. To be very deterministic, or at least to be more apt. to be CSV based so that we can consolidate more stuff. Welcome back, Harry. Things continue well. Targeter behavior group. Oh, behavior comes first, though. Behavior, not type category, behavior. Then group, then entity. We are closing in on function here. It's coming together. Oh, that's tricky. Let's see. Let's zoom in. I think that's Molly. That's Molly. She is my youngest cat. She is currently competing with my oldest cat for being the biggest troublemaker. She is definitely giving him a run for his money. She is all the same trouble, but with kitten energy. Now, the one on the bed is Sammy. She's a little tuxedo. She is kind of one of the middle weights. Mason and Sky are the two bigger ones. Then Sherbet and Sammy are in the middle. Molly is kind of in that territory. Molly's a little chubbier, but not like she doesn't have a lot of fat. She's just kind of football shaped. Again, still a lot of kittens, so body shape still has a little bit of adjustment, not full lanky kitten. Then the smallest by far is Ember. She is itty bitty compared to the others. Ember should be visible here. That's Ember. She is diluted calico. So like pale orange, gray stripes, white socks, that kind of thing. Her right ear is pale orange. She is a complete sweetheart. Just the loveliest cat. Okay, player needs to be a special item. So we need to go into the player entity. And we need a special category for it. It is not just an entity. It's a player entity. Which adds a layer of complexity, annoying, but such is life. This won't actually be a problem in the finished one, it's just a hassle right now. Okay, we go back into base catalog. Hello, Sky. Sky doesn't frequently come to sit with me, but he does periodically. Yeah. Mason kind of rivals Sky in size. It's hard to tell, though, because Sky is really fluffy. Mason is a kind of bristly, short hair cat. Like he has much coarser fur. So his size is much more on display. Sky is older and a bit chubbier, or at least definitely chubbier, but not obese territory, but substantially fluffier. Like there's a whole easily like an inch and a half of fluff in a lot of spots. So you can't easily compare them one to one. Spawner item. Comma. Player entity. Player entity. Spawner item list. Type category. Spawner item list, comma. World map. World. That is our load order. So we also need to load the entity player path. So now we have a constant load order to deal with. So we get all the way down into here. So this is... We're not iterating over file contents. We are getting a... We are going to get our string out of load order, and that is the type to load. So our type name here. I'm sorry. We're going to get that. We're going to get our file contents. This value here, the dictionary of the actual files. We're going to iterate over our load order. So now we have a type, and that will give us that gives us our type name here. So that's type to load. And then our path type pair. Sorry, our path type. We're not doing this yet. This is we are getting the file paths. This is we're reading them in. This is where we're going to parse them. So this is our file content list, and we're going to iterate over it. Type name in load order. Each file content pair in is our file contents type name. Try again. Lockables is a type. Oh. Well, collision gate should be a thing. String to an iCatalogable. What's coming in as collision gate. It should not be getting that high level path. Ah, okay. Info. Because we shouldn't be getting collision gate as a thing. That is not something that should be able to happen. These are the high level ones. The fact that it's getting collision gate at all is weird. Creating catalogables. We're loading in types. We're getting a let's run this again. Right, because we want the parent type is the trick. Therein lies our problem. Because otherwise, when we're loading it... No, how did we do that before? Big old mess to find this in there. And there's something still missing here. Okay, we'd call get directory file contents. Okay. Catalog. Processing. Contents. So we have a type of T. Okay, we know what that is coming in. We are telling it that it is a particular type. All right, we need another way to parse that. So we could make this a dictionary that is the text of it for the load order purposes, followed by a specific type. That way we can translate it back. All right, this is incomplete at the moment. I need to think on this a little bit further. It's largely kind of how I want this to end up. This is interim, but the part that is the bit that we're stuck on is real code. This is, once I get the rest of it working, I will still need this part to work. So this needs a little more wrangling. So we'll hold there for now. Well, I hope you folks had some fun today. It was good to get back in coding. There will be more of this. I don't have the schedule out for the coming week. It will be here either later tonight or into tomorrow. We will be coding at least once a week. I also need to get 100 line continuing to roll. We've got a lot of ground to cover there. Goal with 100 line is to get at least one actual ending. There is a whole lot to the game, enough that I don't know that we're going to stream the whole thing. In fact, I'm confident we won't. But we need to get at least one ending, and then we'll determine if we're going to be hopping to a different game or not. But yeah. Again, I hope you had a good time tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, drop me a comment. Let me know what you liked or didn't. I try to respond to everything, and all of it helps the channel grow. If you would like to consider financially supporting the channel, you can do so through platform-specific means like memberships and bits, that kind of thing, as well as through Patreon and Coffee. There are links to outside sites in the link tree that is in my descriptions and bios. With all that said, I hope you have a good rest of your day, and I'll see you next time.